US Physics Olympiad, year 2013, USAPHO Semifinal exam. Problem A4. A graduated cylinder is partially filled with water. A rubber duck floats at the surface. Oil is poured into the graduated cylinder at a slow, constant rate, and the volume marks corresponding to the surface of the water and the surface of the oil are recorded as a function of time. Water has a density of 1 gram per milliliter. The density of air is neglectable, as are surface effects. Find the density of the oil. Solution. Let's draw additional lines on this graph. Initially, when we check these two lines with small circles and small crosses, they are connected in the beginning of time. It means that oil was absent at 0 point. And in this point, the total water level was V1 equal 243 millimeters. It means that it was total volume of water plus volume displaced by this rubber duck. And after that, we start to fill oil. And in point 6, we see that the rate of this filling was constant. It means that in this point, our duck start to completely float in oil. Now we exclude the possibility that duck floats between water and oil, completely submerged on the oil level. So it means that after 0.6 minutes we have water level is constant, 100 milliliters. And we can subtract from V1 VW, that will be VdW, the volume of water displaced by a rubber duck, which is 143 millimeters. This is how this duck completely floats in water. Now let's check a red line. The slope of a red line showing in the end after 6 minutes how fast is this oil filling this cylinder. And it means that if we continue this line to the beginning, we can find what is the total volume of oil in our container. That will be this amount on the right end of this red line minus this point on the left end of this red line. Let's count it. So we have VO, that's amount of oil in the end of the process, which is 142 millimeters. And if we check this graph now, we can say that this is the level of oil, 385 millimeters. The level of water is 100, and the distance between green line and blue line, that's volume displaced by our duck from the oil. If we count it, we can count this amount. So we see that VDO, that's the volume displaced by a rubber duck from oil, which is 187 millimeters. If we compare these two volumes, this is the volume displaced by duck from water, and this is volume displaced by duck from oil. And now we can find what is rho of oil. So we have this equation: displaced volume of oil multiplied by rho of oil equal to displaced volume of water multiplied by rho water. And now we can find what is raw oil. That will be 0.77 gram per milliliter. That's the answer for problem A4. Only thing that we don't know yet if this rubber duck is floating in the oil or it's completely submerged and floating between water and oil border.